In this video, I am going to discuss about the problem part of ellipse drawing algorithm. Ellipse is somewhat different from circle, so we need to do some modification to get the ellipse drawing procedure. Here, the ellipse having the two different radius, one is major axis, another one is minor axis. And in a circle drawing algorithm, circle can be splitted into equal 8 parts, but here ellipse can be splitted into equal 4 parts. Each part is called a segment. After drawing this particular segment, taking the symmetry for remaining 3 segments, we can complete the entire ellipse. For this particular segment, it can be categorized into region 1 and region 2. The shape of the ellipse can be differ from the region 1 and region 2. Here, x and y coordinate value changing continuously. But after region 1, x value is almost similar and y value decremented on each step. So, the separate formula can be used in a region 1 and region 2. So, in region 1, we have to use this formula. So, in this algorithm, these three are important area. This is for initial decision parameter. Depending upon the positive or negative value, we can apply the next decision parameter. So the problem can be asked like this. They given the x radius and y radius value. First we have to find the intermediate pixels for region 1. First I explore the given value and find the initial decision parameter for region 1. This formula can be taken from the second step of the algorithm. Apply the value, we can get this equation. So 6 square can be 36 and this value can be 64 into 6 and this value can be 64 into 1 by 4. So after simplification we can get this value. So the initial decision parameter for region 1 is minus 332. So we calculated now the initial decision parameter. This value is negative value. So we have to calculate the next coordinate value. So I create a tabular column like this. I repeat this calculation until 2ry square into xk plus 1 greater than or equal to 2rx square into yk plus 1. And I need the starting point. In a ellipse, we are starting from this point only, that is 0, ry. Here ry value is 6. So I write 0, 6. For negative value, we are using this formula, and positive value, we are using that. So I copy this formula here. And for simple calculation, I calculated the 2ry square value, that is 72, and 2 into rx square value, that is 128. These two values for constant for all iterations. For the first step, k equal to 0, and we already calculate the initial decision parameter, that is minus 330. This value is negative. So we are using this formula, that is increment the x coordinate value and keep the same y coordinate value. So the next coordinate values are 1, 6 and calculate this value. So 2ry square is 72. So 72 into 1 is 72 and 128 into 6 is 768. This is the negative value, so we are using this formula. So for finding the next decision parameter, so I write the previous decision parameter, that is minus 332 plus 2ry square into xk plus 1, that is this term, that is 72, plus ry square, that is plus 36. I can get minus 224. So the next entry is k value 1, then pk is minus 224. This is also a negative value. So we are increment the x coordinate value and keep the same y coordinate value. So the next coordinate value is 2, 6 and calculate this term. So 72 into 2, 144 and 128 into 6, 768. Now we need to calculate the next decision parameter value using this formula. So minus 224 plus this term plus ry square, that is 36. We can get minus 44. So I write the minus 44 here. So this is also negative value. So I increment the x coordinate value and keep the same y coordinate value, that is 3, 6 and calculate this term. So 72 into 3, 216, 128 into 6, 768. And we need to calculate the next decision parameter using this formula, that is minus 44, and this term, that is 216, plus ry square, that is 36. We can get 208. I write this value in the next step. So now I can get the positive value. So positive value, I increment the x coordinate value and decrement the y coordinate value. That can be given in the algorithm. So I increment the x coordinate value, that is 4, 5, and calculate this term, that is 72 into 4, 288, and 128 into 5, 640. Then we need to find the next decision parameter value using this formula, because this value is positive value. So 208 plus this term, that is 288, minus this term, that is 640, plus ry square, that is 36. So we can get minus 108. So I write this value here. So this is the negative value. So I just increment the x coordinate value and keep the same y coordinate value. And I find this term, that is 72 into 5, 360, then 128 into 5, 640. This calculation needs some more rows. So I expand this tabular column and calculate the next decision parameter. So this is the negative value. So I use this formula, that is minus 108 plus this term, that is 360, plus ry square, that is 36. So I can get 288. So I write this value. This is positive value. So I increment the x coordinate, decrement the y coordinate, that is I can get 6, 4. Then I find this term, that is 72 into 6, I can get 432. Then 128 into 4, I can get 512. Then I need to calculate the next decision parameter using this formula. So I write 288 plus this term minus this term plus ry square. So I can get 244. So I write the value here. So this is positive value. So I increment the x coordinate value and decrement the y coordinate value. So I can get 7, 3. Then I find this term, that is 72 into 7, I can get 504. 128 into 3, I can get 384. So for all these calculations, this term always lesser than this term. But in this stage, this term can be greater than this term. That is, we satisfy this condition. So we stop the calculation for region 1. I illustrate the calculated values and try to draw the region 1 calculated pixels. So the initial point is 0, 6. So I draw the pixel in this coordinate. Then the next value is 1, 6. Next value is 2, 6. Then 3, 6. Then 4, 5. 5, 5. 6, 4. And 7, 3. So we completed the region 1 part. Now we move to the region 2. The region 2 starting pixel is end of the region 1 pixel, that is 7, 3. And we use the different formula given in the algorithm. So this is the initial decision parameter for region 2. Depending upon the positive or negative value, we are using the next decision parameter formula. So I write the given values for region 2 and start from 7, 3. So this is the initial decision parameter formula for region 2. Then I apply the values here. So here the x0 and y0 is starting point of region 2, that is 7, 3. So I substitute this value here, so I can get this equation. So after simplification, I can get this value. So finally I can get the value for initial decision parameter for region 2 is minus 23. Like region 1, I can draw the tabular column. I repeat the calculations until the yk plus 1 reaches the value 0. That is, it reaches the x-axis value. So the starting point is 7, 3. That is the end point of the region 1 value. And I write the formula given in the algorithm. In the algorithm, the second part is dealing the positive value. Just note this difference between the region 1. So in a Bresenham's line drawing or circle drawing or ellipse drawing region 1, the first decision parameter always discussed with the negative value. But in region 2, after calculating the initial decision parameter, it discussed first the positive value. So note down this difference. So I first write the positive value formula here and negative formula. So in the first step, I write the k value is 0 and calculated the initial decision parameter, that is minus 23. So this is negative value. So I can use this formula. So increment the xk value 1 and decrement the yk value. So the next pixel is 8, 2. Then I calculate this term. That is 2ry square, that is 72 into 8, I can get 576. 128 into 2, I can get 256. Then I need to calculate the next decision parameter. So this is the negative value. So I can use this formula. So the next decision parameter is minus 23 plus this term, that is 576, and minus this term, that is 256, plus rx square, that is 64. So I can get 361. I write this value here. So this is the positive value. So for positive value, so I can use this one, that is keep the same x value and minus 1 for the y coordinate. So this is 8, 1. Calculate this term, that is 72 into 8, I can get 576. 128 into 1, I can get 128. Then I need to calculate the next decision parameter using this formula. So 361 plus this term plus rx square. So I can get 1001. So I write this value. So this is positive value. So I can keep the same xk value and decrement the y coordinate value. So 8, 0 is the result. So I calculate this value, that is 72 into 8, 576. 128 into 0, 0. Now the y coordinate value reached the 0. So I stop the calculations for region 2. That is the destination pixel is 8, 0. That is the end of this quadrant. So the previous plotted graph from the region 1, I can continue with this value. So now I take the region 2 values, that is after 7, 3, the next coordinate values are 8, 2. So I can draw the 8, 2 dot here, then 8, 1, then 8, 0. So now we complete the ellipse for this particular quadrant. So after this we can take the symmetry and complete the remaining quadrant to get the complete ellipse. So in this way we can calculate region 1 and region 2 and plot the graph like this to solve the ellipse drawing problem. Thank you.